common factor and least common multiple using prime factorization. Now, I like using prime factorization and find it helpful when working with numbers that are a little larger in value and not as simple to work with. For example, the strategy of listing out all of the factors or listing some multiples of the numbers you're working with can be kind of difficult and time-consuming when working with larger numbers in value. So prime factorization is a different approach, a different strategy to be familiar with when it comes to finding the greatest common factor or least common multiple. Let's start with the greatest common factor and jump into our examples, starting with number 1, where we have 63 and 84. Let's start with the prime factorization of 63, and we will start with the factors of 7 and 9. 7 times 9 equals 63, so 7 and 9 are factors of 63. Now 7 is prime, so we are done there. 9 we can break down. 3 times 3 equals 9, so 3 is a factor of 9. 3 is prime, so we are done there and there. And that's the prime factorization of 63. We can't break that down any further. Now we have the prime factorization of 84. Let's start with the factors of 2 of 84. Let's start with the factors of 2 and 42. 2 times 42 equals 84. So 2 and 42 are factors of 84. Now 2 is prime, so we are done there. 42 we can break down. 2 times 21 equals 42. So 2 and 21 are factors of 42. 2 is prime, so we are done there. 21 we can break down. 3 times 7 equals 21. So 3 and 7 are factors of 21. 3 is prime, and 7 is prime as well. So we are done. That's the prime factorization of 84. We can't break that down any further. Now that we have the prime factorization of both of those numbers, we need to find common prime factors. So prime factors that they share. Now I'm going to list the prime factors of each to make it easier to find the ones they have in common. So as far as 63, we have 3, 3, and 7. 3 times 3 times 7 equals 63. For 84, we have 2, 2, 3, and 7. 2 times 2 times 3 times 7 equals 84. Now we need to find any common prime factors. 3 is a common prime factor, and 7 is a common prime factor. So they have a 3 and a 7 in common. Once we find those common prime factors, we multiply them. So 3 times 7, and that equals 21. And that's our greatest common factor. So the GCF, the greatest common factor of 63 and 84 is 21. Let's move on to number 2, where we have 48 and 72. Let's start with the prime factorization of 48. And we will start with the factors of 2 and 24. 2 times 24, 24. 2 times 24 equals 48. So they are factors. Now 2 is prime, so we are done there. We can break down 24. 2 times 12 equals 24. So 2 and 12 are factors. 2 is prime, so we are done there. We can break 12 down further. 2 times 6 equals 12, so 6 equals 12, so 2 and 6 are factors. 2 is prime, so we are done there, but we can break 6 down further. 2 times 3 equals 6, so 2 and 3 are factors. 2 is prime, so we are done there, and 3 is prime, so we are done there as well. And we are done with the prime factorization of 48. We can't break that down any further. Now we need the prime factorization of 72. Let's start with the factors of 2 and 36. 2 times 36 equals 72, so they are factors. 2 is prime, so we are done here. 36 we can break down. 2 times 18 equals 36, so 2 and 18 are factors. 2 is prime, so we are done there. 18 we can break down. 2 times 9 equals 18, so 2 and 9 are factors. 2 is prime, so we are done there, but we can break 9 down further. 3 times 3 equals 9, so 3 is a factor of 9. 3 is prime, so we are done there and there. And we are done with the prime factorization of 72. We can't break that down any further. Now that we have the prime factorization of both 48 and 72, we need to find common prime factors. So I'm going to write the prime factors of 48 and 72. That way it's a little easier to find common prime factors. For 48, we have 2, 2, 2, 2, and 3. So 2 times 2 times 2 times 2 times 3 equals 48. For 72, we have 2, 2, 2, 3, and 3. 2 times 2 times 2 times 3 times 3 equals 72. Now we need to find common prime factors. They have a 2 in common, another 2 in common, another 2 in common, and then a 3 in common. So now that we found the common prime factors, we need to multiply them to get the greatest common factor. So we have 2 times 2 times 2. They have 3 2's in common, times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. So the GCF, the greatest common factor of 48 and 72, is 24. So there's how we use prime factorization in order to find the greatest common factor. Let's move on to least common multiple. Here are our examples for finding the least common multiple using prime factorization. Let's jump into our examples, starting with number 1, where we have 15 and 27. Let's start with the prime factorization of 15, and we will start with the factors of 3 and 5. Now 3 is prime, so we are done there, and 5 is prime, so we are done there as well. And that's the prime factorization of 15. We can't break that down any further. Now we have the prime factorization of 27. Let's start with the factors of 3 and 9. 3 times 9 equals 27. So 3 and 9 are factors of 27. 3 is prime, so we are done there, but we can break 9 down. 3 times 3 equals 9. So 3 is a factor of 9. 3 is prime, so we are done there and there. And that's the prime factorization of 27. We can't break that down any further. Now we're ready to move to the next step. So we need to list the prime factors of 15 and 27 and match them vertically. Let's see what this looks like, starting with 15. So our prime factors from the prime factorization are 3 and 5, or 3 times 5. Now for 27. So we have 3 times 3 times 3. And you'll notice that 3 times 3. And you'll notice that big gap underneath the 5 there. We are matching numbers vertically. 27 does not have a prime factor of 5, so I left that blank underneath the 5. Now that we have our prime factors listed and matched vertically, we move on to the next step, where we bring down. And I like to draw a line underneath here in order to separate these steps. So this is a column, and although we have 2 3s here, this is a column of 3s, so we just bring 1 down. We have a 3 to represent that column of 2 3s. Times, we have a column of 5 here, times, we have a 3 here, times another 3 here. So we end up with 3 times 5 times 3 times 3. And by multiplying these, we get our least common multiple. So 3 times 5 is 15, times 3 is 45, times 3 is 135, times 3 is 135. And that's our least common multiple. So the LCM, the least common multiple of 15 and 27, is 135. Let's move on to number 2, where we have 28 and 52. Let's start with the prime factorization of 28. Now 2 times 14 equals 28, so let's start with those factors. 2 is prime, so we are done there. 14 we can break down. 2 times 7 equals 14, so 2 and 7 are factors of 14. 2 is prime, so we are done there. And 7 is prime as well, so we are done there. And that's the prime factorization of 28. We can't break that down any further. Now we need the prime factorization of 52. Let's start with the factors of 2 and 26. 2 times 26 equals 52. So 2 and 26 are factors of 52. 2 is prime, so we are done there. 26, we can break that down. 2 times 13 equals 26. So 2 and 13 are factors of 26. 2 is prime, so we are done there. And 13 is prime as well, so we are done there. And that's the prime factorization of 52. We can't break that down any further. Now we need to list the prime factors and match them vertically. For 28, we have 2 times 2 times 7. For 52, we have 2 times 2 times 13. Now we need to bring down. So we have a column of 2's here, so let's bring down. So we have a column of 2's here, so let's bring down a 2 to represent that column, times another column of 2's, so let's bring another 2 down, times 7 times 13. So we have 2 times 2 times 7 times 13 to get our least common multiple. We have 2 times 2, which is 4, times 7 is 28, times 13. Well, I'm not sure what 28 times 13 is, so let's come to the side here and multiply. 28 times 13. We will start with 3 times 8, which is 24. 3 times 2 is 6, plus 2 is 8. We are done here and done here. We need a 0. Now we have 1 times 8, which is 8, and then 1 times 2 is 2. Let's add. 4 plus 0 is 4. 8 plus 8 is 16. And then 1 plus 2 is 3. So we get 364. So the least common multiple of 8 and 52, let me squeeze this in here, is 364. So there you have it. There's how to find the greatest common factor, the GCF, and least common multiple, the LCM, using prime factorization. I hope that helped. Thanks so much for watching. Until next time,